right, so I think let's get started. Welcome everyone to our last seminar of VQMS for the spring semester. We're happy to have Elisabeth Honka with us to do the talk. Quick reminders about the structure. We'd go for about 45 minutes on the talk, or up to an hour with Q&A. Feel free to put your questions in the Q&A box, and afterwards we'll just stay here for more informal discussion about the paper. For panelists, feel free to unmute yourself and ask questions right away. And one last announcement for the summer. We'll go in a short break, and then sometime in the middle of summer we'll announce our plans for the fall, when we'll continue with the seminars. All right, Ella, welcome, and take it away. The floor is yours.
Okay, thank you very much, Andre. Good morning, everybody from the West Coast. I'm going to present a paper today on search gaps. The paper is joint work with my two wonderful co-authors, Zhang and Raluca Ursu, both from NYU. And so I fully plan on having Raluca answer all the difficult questions that I'll get today. Okay, so, whoops. Okay, so the main motivation for this paper is fairly brief. We all know that, whatever we want to buy, whether that is a kitchen scale or whether that is a TV, consumers face many, many options before the purchase on which product they can buy. And so there's a rich search literature that models which options or which products consumers investigate or search, and which products get ignored. And so there is both a theoretical as well as an empirical literature that has made different assumptions on the type of products that consumers search, on the search method that they use, and a lot of other questions. So I'm going to focus on the sequential search model today. So everything that will follow here is under the assumption that consumers search sequentially. And we're going to start out with the classic Weitzman sequential search model. So in the sequential search model, we usually model three decisions. So the first is, in which order do consumers search? So which option would they potentially search first, second, third, and fourth? The second question is, well, how many options do consumers actually search? Are they going to search 1, 2, 3, or 4 options? And when do they stop searching? And then the last one is conditional on having decided that I'm going to stop searching. Well, which one am I going to purchase, if at all? So the outside option is also possible. So in the sequential search model, as the name already says, consumers search sequentially, and there is only one stopping decision that consumers make, and that is when to stop searching and make the purchase decision. However, if we look at typical consumer browsing data, the pattern looks somewhat different. And so let me briefly explain what you see here in front of you. So this is browsing data for one consumer over a time period of 11 days. And here we focus on the time period between about 4 p.m. and 9 p.m. And the purple dots are apparel clicks. So when did the consumer click on a website or on a page that is related to apparel? So that's going to be the category that we focus on. The gray clicks are non-apparel clicks. So they might be email, might be browsing, banking, social networking, everything else that you can do online. And so let me just introduce a little bit more terminology that you're going to hear throughout the paper. So these sequences of consecutive clicks, we are going to call them sessions. And the session is defined as a sequence of clicks with no interruptions longer than 30 minutes. So if consumer pauses for 30 minutes, then a new session starts. And so here we see that the consumer had a had a session where the consumer clicked on apparel clicks on Tuesday the 20th, then took a 2-day break and had another session where the consumer did look into the apparel category on the 22nd and the 23rd, and then again on the 27th. So we see that the consumer takes break. Here there is a 2-day break. Here there is a 4-day break between sessions in the same category. The brown dot that you see here on March 2nd is an actual apparel purchase. So on March 2nd, the consumer decided to buy a piece of clothing. Now, for the purpose of the paper, we define gaps or breaks between sessions as search gaps. So here is a search gap of 2 days between one session where the consumer searched for a clothing product and another session where the consumer searched for a clothing product again 2 days later. And here is a gap of about 24 hours. So the consumer searched in a session around 5 p.m. on the 22nd, and then took a 24-hour break and searched a day later around between 6 and 7 p.m. for apparel products today again. So in this paper, what we are really interested in studying are those gaps. Why do they occur? How often do they occur? How do they influence consumers' decision making? And one last piece of terminology. So this whole sequence of 11 days where the consumer searched for apparel product across all of the days is what we are going to call a search spell. And such a search spell can result in a purchase, but can also end with a no purchase as well. Okay, so just coming back and putting it more into pretty pictures and into the modeling framework that you saw just 2 slides ago. So typically in a Weitzman model, we think of search as happening, as you can see here. So the consumer searches the first option, then the second option, then the third option. But I just showed you some browsing patterns of consumers online that suggest that consumers actually search differently. They might search one option and then take a break. So that's the search gap I was talking about, and then search a second and the third option. Or they might even take 2 breaks, 2 search gaps between the first and the second and the third option. So we're going to try to understand better what drives these search gaps and what are their effects and how can we model them within a sequential search model. So search gaps have been so far ignored by previous literature for several reasons. So the first being that in many papers, those gaps are simply not observed in the data. Such data might be based on surveys, for example. They might be assumed away or grouped together, meaning that all these sessions that happened over the course of the 11 days that you saw a few slides ago might be just grouped into one spell and modeled without these search gaps. And in some cases, they might either be assumed to be independent or the data is at the session level so that the researcher cannot connect the different search sessions across the 11 days. And so ignoring search gaps is okay as long as they happen for reasons that are unrelated to search. But what I'm going to show you later on is some descriptive evidence that these search gaps happen for reasons that are deterministic, that are endogenous, that the consumer decides to take a break. And so why might consumers decide to take breaks? There are multiple reasons possible. So one might be that the consumer expects certain product features to change over time. So think about buying flights. You might want to check back a day or 2 days later to see whether prices are going to change. They might also be due because the consumer does not quite know what to search next. And a third reason might be that the consumer just gets tired of searching. And so this is also the explanation that we are going to focus on here in this paper. So we are going to model how consumers get tired of searching, and this tiredness is going to increase consumer search cost of an additional search. And so they are going to take breaks or search gaps to lower their search cost. Now, obviously, that is most likely not the only reason that drives these search gaps, but I'm going to show you some evidence later on that it is definitely one of the major reasons. And so we focus on that one throughout the paper. Okay. There is also plenty of evidence in the popular press that consumers do get tired of collecting information online, of searching. So here are just clips from a few articles talking about consumer fatigue, consumers getting tired of the search process. And so the goal of this paper is really to, first of all, kind of show you that search gaps happen when consumers browse online, that they happen frequently, to provide some evidence that they are at least partially related to fatigue, so consumers getting tired of searching, and then to develop a sequential search model that incorporates this fatigue and can predict when consumers are going to take breaks, and that is also tractable. And so when we're going to get to the model, you're going to see why I'm talking about the model being tractable, because it's actually quite complicated to model that. So just as kind of a preview, the sequential search model is not only going to have the selection rule, so in which order do consumers search, it's also going to have the search rule, but that search rule is going to not only predict when consumers stop or continue searching, but also whether, if they decide to continue searching, they do it now or after a break, after a search gap. And the choice rule remains the same. So I'm going to take a break now. If there are any questions, Andre or Raluca, please let me know.
Yeah, there are a couple of questions. So Qianyun is wondering how we think about the reason for search gaps across different categories. There might be different explanations across different categories.
So yes, I agree. There might be different reasons. We focus on the apparel category. So, and I'm going to show you again evidence that at least for that category, fatigue seems to be one of the major drivers of search gaps. But as I was saying previously, for other categories, excuse me, it might be that search gaps are driven by other factors, such as expecting prices or other product features to change. So yes, there can be different reasons depending on the category.
And there are a few questions about sort of the data, which I think you're going to talk about next. So maybe we can get to those then.
Okay. Okay. So then if there are no more questions, I'm just gonna continue. So the data comes from GfK, which is like the European ComScore company, and we have browsing data for about 5,000 consumers over a time period of 10 weeks. And so we have about 8 million observations and 3,000 transactions. And we observe all sessions in which the consumer clicked at least once on a page related to apparel. And we not only observe those clicks on apparel pages, but also all other clicks that happened in that same session. And those might be on social networking, gaming, or on some other websites as well. So let me show you an example of how the data looks like. So here's a session starting for consumer number 1. And at the beginning of the session, the consumer goes to Facebook and spends about 7 minutes on Facebook. Then the consumer goes to a news site and spends about 2 minutes on there. Afterwards, we see that the consumer goes to H&M, which is a European apparel company, goes to a product page, picks a product, a specific product, adds the product to a cart, and then checks out. And so that happens in this example relatively quickly within about 2 minutes. And afterwards, a couple minutes later, the consumer decides to go and check his emails. So we observe all of the browsing activities within those sessions. And then additionally, we also have information on, for example, demographics. We know which subcategory or of apparel products the consumer looked at. So in this example, the consumer looked and purchased shoes. We know whether a transaction happened and what the price of the product was. So we have a lot of information. And just by the way, this classification of the activities into the different categories was done by GfK, not by us. Okay. So let me now show you how often consumers take breaks, how frequent search gaps are. So what we did here is we looked at the 7 most frequent apparel categories, and they are ordered in by their search frequency. So consumers most often search for shirts, tops, blouses, then shoes, then pants and jeans, etc. And the first line here shows you the percentage of search spells that had at least one gap. So where consumers took at least one break during the search spell, and you can see that these numbers vary somewhere between 36 to 60%, and on average across all of these categories, 43% of search spells contain a gap. Now, do consumers usually only take one break? The answer is conditional on taking at least one break. They commonly take more than one break. I think the average number of breaks is about 3. So you can see that, for example, for shirts, tops, blouses, it's the average number of breaks is 2.8. For shoes, it's actually quite higher with 5. So the takeaway from this slide is hopefully that you are convinced that search gaps do happen. Consumers take breaks when they are browsing for products online, and they commonly take more than one break. I'm going to take another break and just see whether there are any questions related to the data and the data patterns.
Yeah, there's one question about how to define the spell, especially if people don't make a purchase or they make multiple purchases. How do we think about the definition, I guess?
So if consumers make a purchase, then the search spell ends with that purchase. If consumers don't make a purchase, it's the last time that they searched for a specific category of apparel products.
Can I ask a question as well?
Absolutely.
Within each of the categories, of course, you look at the spell of that. Do you see the categories kind of crossing over through a search spell? Like they were doing shoes and they switched to blouses. Do you know how frequently that happens?
So Raluca, that's a question for you.
I don't know how frequent. I mean, it happens frequently that people go from one. I don't know exactly the percentage. We look. I mean, in each of these, all the results you'll see, we looked kind of at searches across within a category. But yeah, people might be searching for shoes and then for shirts, so we think of those as independent searches.
It might be interesting just as a means of thinking through what's the cause of the search fatigue. If you're saying I get bored of shoes and switch to blouses, that's different than I am just tired of searching for things online, right?
That's true. I think that's something that we can look at. How often do people kind of go back and forth between the different categories? So thank you, Brandon. Any other questions?
Just a quick clarification question. I think I might have missed it. How do you deal with like the borders of your data set, right? Like, because you don't have a very long period.
Yes, so we cut them. So we cut them basically. That's the short answer. I think we dropped the first 2 weeks of the data time period to make sure that we observe the whole search spell from the beginning. And then at the end, Raluca, do you remember how much?
Yeah, it's I think it's 4 days or something like that at the end if there was no purchase in that last session. So if it occurred within the last 4 days and there was no purchase there.
Thanks.
You're welcome. Okay, so let me tell you a little bit about the empirical patterns and why we think that fatigue is a driver or a major driver in, at least for this product category. So first, I'm going to show you some evidence that consumers decide when they want to take gaps, so that basically that these gaps are not exogenous. So one piece of evidence is to look at what do consumers actually do during the search gaps. Is there that, you know, they had to run away because, I don't know, their dinner was burning on the oven? Or is it that, you know, they actually had some additional time that they could have spent on the fashion websites, but that they decided not to do so? And so what we observe in the data is that about 90% of the consumers do stay online and just engage in other online activities after they decide not to search for apparel products any longer. And these activities are usually leisure activities. So it's not something that points, for example, to a work email that had to be answered immediately. So here is just a graph showing you the most popular activities after apparel clicks. And this graph also holds for the evenings and the weekends. And yes, email is the most frequent one. But again, social networking, surveys, search engine, and the other types of categories point to a very large proportion being leisure activities. While we don't observe sessions in which consumers did not make any apparel clicks, we do observe what happens when consumers do something else than search for apparel products within a session. And the picture is very similar to what you previously showed, that yes, people answer a lot of emails, which might be work related, but might be, you know, from family and friends as well, but they also engage in a lot of other leisurely activities. So it seems to indicate that consumers could have searched longer, but they decided not to do so. And lastly, we also look at what happens when a consumer actually gets an email during the search. So when consumers get an email notification while they are searching for fashion products, what we observe is that over 90% of consumers come back and they continue their search after addressing the email. So this is just some descriptive evidence pointing to these search gaps, these breaks in the search process, again, being deterministic. The next piece of evidence that I want to show you is that they are related to fatigue. And so we don't directly observe consumer fatigue. So what we try to do is to proxy for it. And so we're going to do it in multiple ways. We first look at consumer demographics, time variables, and website characteristics. And we also look whether the number of options that the consumer has searched, either since the beginning of the search spell or since the last break, affects the probability of the consumer taking a break. And so I think there are two things that are really important to keep in mind for this talk going forward. So the first is that when I talk about options, I mean websites. So what we look at and what we model also in this paper is search over websites, not over clicks or of visiting a specific product page. So we had discussions about this, like going back and forth. And so what we basically, the conclusion we came to is, consumers are probably not going to get very tired from making one click on a specific page, but having spent 10, 15 minutes on a AHM website searching for shirts or on Zalando searching for shoes, that can really tire you out. So an option to be searched throughout this paper is a website. And the second point is that in the empirical section that is going to start right now, we focus on 2 out of those 9 apparel categories that I've been showing you so far. And we pick the 2 ones that are searched the most frequently: shirts, tops, blouses, and shoes. So I'm always going to show you results for both of these categories. Okay. So here are a few regressions for these 2 apparel categories, where the dependent variable is the number of gaps in a search spell, and we relate that to these 3 types of variables: consumer characteristics, time variables, and website characteristics. And so one thing here when it comes to the consumer characteristics that we see is that older consumers take more breaks. And we know from medical literature that older consumers get tired more quickly. We also find that consumers are less likely to take breaks during the evening, when they have less time restrictions, for example, related to work. And we also find that breaks are related to the readability of a website as well. So if it's hard to read, if it has a lot of words, consumers are going to take more breaks. And second, we look at, after each search, is the consumer taking a break or not? So we have a search gap indicator, and we relate that to the cumulative number of searched websites prior to this decision, as well as alternatively to the total time spent searching. And so these are the results that you see here. And we find significant positive effects of both. So if the consumer has searched, the more websites a consumer has searched since the last break or the beginning of the search, the more likely it is that the consumer will take a break. And the same applies for the total time spent searching. Questions?
There's one more question asking whether search gaps can happen because people expect promotions. So, they just wait for a lower price or something like that.
So it's possible. However, what we look here at a relatively short time period of 8 weeks. And in that short time period, there were no major promotional time periods. And I think we also looked at whether there were any sales happening around Easter and any price changes around that time. And we didn't find any evidence for that. So it's not conclusive that I can completely rule it out, but I would say it's not likely in this specific data set. Any other questions? No? Okay. So then I'm going to get to the meat of the paper. Okay, so the search model. So the setup of the search model is very standard. So there are J websites. We're going to denote the search websites by capital S, the not searched website by capital S bar. There's going to be an outside option. And searching a website reveals the utility, the actual utility of the website. Y is going to denote the best option searched so far. The first point here is that we are going, as I mentioned, going to model search costs to be increasing with the number of searches the consumer has made since the last break. So search costs are going to have a baseline search cost component. So that's this CJ naught. And they are going to have this term alpha t, where alpha is a parameter to be estimated, and t again is the number of options searched since the last break. And so the search model can be written as follows. So the consumer is going to maximize make decision to stop or to continue searching. And so if the consumer stops searching, the consumer gets the payoff Y, so the best option searched so far. If the consumer is going to decide to continue searching, the consumer is going to get this search value fee. And the search value fee has two components. One describing the payoff for when the consumer decides to search now versus when the consumer decides to search later. So when the consumer decides to search now, the consumer is going to pay the baseline search cost and these additional costs due to fatigue. So these are the total search costs CJ here, and is going to get the payoff here. But if the consumer is going to decide to postpone searching, then at a later point in time, after the break, the consumer is going to have lower search cost. He is only going to have to pay these baseline search costs, CJ naught, but the payoff is going to be discounted by this discount factor beta. And so this is the complete search problem. Unfortunately, it's not easy to solve or find an optimal solution for it, a la the 3 Weitzman rules. Actually, it's not possible for this search problem as written here. So first of all, yes, Zhang.
So I just have a quick question. It seems that I cannot type in the Q&A section. So I will just ask it out.
Please, go ahead.
Thank you. So I think in the Weitzman framework, and one possibility that is not able to consider, we're not able to consider is the, so I would call it hesitation between two options. Mm-hmm. So when you start to accrue options into your consideration set, right, and the options that you have searched, and it's more and more likely, and so it may be more and more likely there are two items that have very similar utility to one another. Mm-hmm. Right. Let's say so at this stage it may become indecisive from the perspective of the buyer, of the consumer. So can that also cause the gaps? So with mm-hmm. the consumer and has a hope that there will be some random shock appearing during the gap that will break the tie.
So when you say that two options are very similar, you mean that two searched options are very similar?
Two searched option who you have searched.
Okay.
Are very similar to one another.
So I think we stay kind of within this rational consumer assumption that even if, you know, one option is only slightly better than the other, a consumer is going to pick the option with the highest utility. We also stay within the framework that, you know, the search reveals everything about a product. So there is no other new information kind of coming. But this is kind of the model that we think in. Would it be possible to write out an alternative model that kind of would describe the patterns that you are talking about, you know, hesitancy or, you know, wanting a certain differential in the utilities, or maybe anticipating that there might be some changes in the product characteristic or some new information coming in? I think it would be possible. It's just that's not the type of model that we are writing out, and that we are focusing on thinking that having provided kind of the descriptive evidence supports the model that we've chosen to develop. Does that address the question? Good. Okay. I think are there any other questions, Raluca? I'm just, I have stuff popping up on my screen, so that's why I'm asking.
Not really.
Okay. Okay, so I'm just going to move on. There is no index solution for this problem. So why is there none? So just going back a few steps, if the search breaks are exogenous and the search costs are constant, we are back into the kind of classic Weitzman model, and we all know what the optimal behavior on the consumer side is for that type of model. However, if we just change the assumption of constant search costs to increasing search cost, that we are already in a world where there is no index policy. Because why the payoff from the options might be independent, searching one option increases the search cost of all of the other options, and that makes it not to be independent anymore. And then in our case, there is kind of this additional, let's call it complication or pattern, that we also want to model of the search gaps, and the search gaps being endogenous, not exogenous. And so not surprisingly, there is again no index policy. And this problem is similar to the bandit superprocesses, but it's not exactly the same. And we also had discussions and conversations about that. And if anybody would like to know, I'm happy to chat about that after this presentation, just to kind of keep it short. So what can we do? One solution that some authors have pursued is to just develop a one step look ahead solution. And that is also something that is in the paper. But another way to address this issue is to see whether there are any simple additional assumptions that we could make, which could make this model tractable, estimable, and would give us an optimal solution for it. And so that's the route that we are going to take. And the desired solution should continue to have, you know, the three known rules of the selection rule. So which options to search next, or in which order to search the options. The search rule, not only saying whether to continue or to stop searching, but now also to address the question of whether the consumer wants to search now or later. And then finally, the choice rule, whether and what to purchase. So that's kind of the goal, and just keep this goal in mind as I go through the next slide. So that is what we want to achieve. Now, let's take a look at the selection rule. So the first issue is that depending on T, so that is this variable capturing the number of websites searched since the last break, the search order or the optimal search order can change. So that's going to create trouble for us. And ideally, we would like the search order to be constant or the same across all the t's. And so the additional assumption or condition that we impose to achieve this is the monotonicity condition, that the difference in the continuation values of two options stays directionally the same. And justifiably, the reviewers, these papers under review, have asked us, how likely is this condition to hold? How stringent is it of an additional assumption that you are making? And so we've run some simulation studies, and thankfully for us, it seems to be a relatively mild condition. So in all likelihood, this holds anyway. And so what we can say is that under this monotonicity condition, the optimal search order for our search problem that also models the search breaks is the same as in Weitzman. So the selection rule, given this additional assumption, is going to remain the same. So calculate the reservation utilities the same way as in the Weitzman model, and order all of your options in a decreasing order of the reservation utilities. For the search rules, so there again, we want to develop simple or tractable search rules which are going to describe whether the consumer searches now, later, or stops searching. We also have to make an additional assumptions, which is going to capture how the continuation values for different t's are related to each other. So here, the continuation value for t+1 is the same as the continuation value at t=1 plus this additional term delta times t. So fatigue is going to affect consumers' decision-making in two places. In this model, it's going to change search cost and also have this effect on the continuation value. So one thing to note here is that this continuation value is actually the same as in the Weitzman model, which then allows us to write out the search rules that are as follows. So for this problem of whether to stop searching, continue and search now, or continue and search later, we can write out the conditions under which each of these three decisions is optimal for the consumer. And so this is what you see here later. And I know that they don't look very pretty, but we can actually make them look quite pretty. So let me show you how. So first note that the two terms in the blue squares are identical. And what we can do is we can solve for kind of, think of it this as a new type of reservation value that we are going to call Z1, okay? These two terms in the red squares are also identical, and we can rewrite them as a solution of a second type of reservation value. And then these two terms in the yellow squares are again the same, and we can write the solution as a function of a third type of reservation value. And so having this on hand, we can write the solution in terms of the optimal consumer behavior for this sequential search model, as you can see here. So for the selection rule, that remains the same type, the same rule as in the Weitzman model. So the options are going to be ordered in terms of the Weitzman reservation utilities. For the search rules, we now, so the difference here is that there are three new types of reservation utilities that have to be calculated. And so once those are calculated, and J is the option with the largest reservation utility, the consumer can simply decide whether to search J now if Y, the option, the best option searched so far, is smaller than the maximum of these two reservation utilities, but larger than the third reservation utility. Then searching now is optimal for consumers. And you can see here when it is optimal for consumers to search later or to stop searching at all. And lastly, the choice rule remains the same. So this is the solution to this search problem. And the estimation, how we are going to estimate this model is very standard. I think, I'm just going to go very briefly over that since I'm running out of time. So these three rules give us some restrictions that we can impose, and then we are going to use simulated maximum likelihood to estimate the model. The identification of the model parameters is also relatively standard. I think the one new thing here is, the search costs don't affect the purchase decision, and they are identified from the number of searches. So that's relatively standard. And then the search gaps are the ones that identify the fatigue parameter conditional on the observed search sequences. Are there any questions at this point in time?
Yeah, John V is asking whether perfect recall without a cost is allowed. And if so, if we observe multiple visits or revisits.
Yes, so this is a model under the assumption of perfect recall. We did observe, I think, in the raw data, some revisits, if I remember correctly. And so we make the simplifying assumption basically that we look at the first visit, and that is the one that we model in the data. Yeah. Andre?
Ella, can I ask you about estimation?
Yes.
Would it make sense? Would it work in this case to try to estimate this alpha parameter just by using some exogenous shocks to, like, you taking a break? Let's say you got an email. If we think about the model and just tired of searching, I got an email, rested for an hour within the email, and now comparing my probabilities to search, not to search, and what to search before, after this exogenous break. Would that work before we get to the full model?
So I think it would be great to have some exogenous variation. So I totally agree with you. I'm not sure whether the email thing would work. That's just my concern. And so that's why we didn't go down that route. And it's also that we don't know whether it's a leisure email, whether it's a work email, and we didn't do the classification. So we were kind of staying away from that. And we don't observe directly. As I said, what we do know is that consumers mostly engage in leisure activities afterwards. So it does not seem like this is driven by some exogenous shock, let's put it like that. Okay. Any other questions?
Could you clarify the delta T assumption there on the continuation value? The thing that I'm wondering about is that it seems like, the continuation value is an endogenous thing. So should I think about this as just, is it forcing a particular functional form with delta T, or is this more like a guess and check sort of, like, I think it's like this and then solve it out, and lo and behold, the continuation value does behave this way.
So it's forcing a particular functional form, but Raluca, that's your area of expertise.
Right. That's correct. We don't know what these functions look like. We know that the one that depends on T is bigger than the one where T is 0. but otherwise we really don't have an idea, right? These are functions of infinitely many decisions that consumers make in the future. So so we're trying to make the, the assumption that allows us to estimate sort of the model here, and that is consistent with our results so far, that one is larger than the other. But yeah.
And when you throw it in and estimate the model, you actually will have the continuation value computed at the end, right? So you can do like a guess and check afterwards, right? To say, we thought it was going to behave this way, it does, or is that not possible?
The only way we can know this continuation value is if we assume, let's say, consumers consider things one step ahead or 2 steps ahead or n steps ahead, and then compute it and plug in values and check. So we can do this with 2 steps ahead, for example, and we're working on that right now.
Okay.
Any other questions? Okay, so let me just briefly go over the empirical application, since I've kind of run out of time. So so we want to model consumer search across the different websites for these 2 fashion categories. And so we define a relatively simple utility function that has website intercepts. We control for some other observed variables, and then this utility function has 2 error terms. So this is going to be an epsilon search model. There is 1 error term eta ij, that is what the consumer observes before search, but is not observed by the researcher. And then we have our epsilon, what the consumer does not observe before search, but what is revealed to the consumer during search, but is not observed by the researchers, neither prior nor after the search. And then we estimate the search cost as I described before, and we just have these exponential functions to ensure that those parameters are positive. As I said, this is estimated using simulated maximum likelihood. And so I'm going to briefly show you the results here. We estimate 3 different models, 1 simple model accounting for search gaps. So that is the first column here. This is for the shirts and tops category. This is for the shoe categories. Then our full model in the middle. And then we also estimate the Weitzman model, which ignores the search gaps. I think one just very brief comment that here is that we actually estimate the utility of the outside option, but what we did is to set the brand intercept of our composite website of all other websites to 0. So that's why you see an estimate on the outside option here. And that's for some technical reasons. We thought that there would be the more appropriate way, and I'm happy to discuss that as well. Looking at the website intercepts, they show the expected pattern. So C&A, for example, has the largest brand intercept, the largest website intercept in the shirts, tops, blouses category. C&A is a large European clothes store. And then we see here that Zalando for the shoe category has the largest website intercept. We are looking at the search costs. What we do see is that the baseline search costs are smaller than the cost associated with fatigue. So fatigue plays a relatively important role in the search decisions. And that's all that I have on the results. So let me just very briefly to go over the counterfactuals, and then I'm going to open it up for all questions that people might still have. So what we first look at is what is the effect of lowering fatigue, and especially compared to making a change to the baseline search cost. So that's kind of the scenario that search papers usually look at, what happens if you lower search cost, baseline search cost, but we look here at what happens compared to that when you lower the fatigue. And so what we see overall is that reducing the fatigue cost by 50% or the search cost by 50%, reducing fatigue has the larger effect in terms of increasing the number of searches, the number of purchases, and decreasing the number of search gaps. We then look how these changes vary across the different websites in our data set. And so what we've done here is on the left-hand side, we've ordered the website by their search shares, and here on the right-hand side by their market shares. And so we find that changing the fatigue has a relatively constant effect, or in terms of percent, actually similar effects on the searches, but it does change with the market shares. And then in a second exercise, we look at, well, what happens if taking a break does actually not lower your search cost? So remember, the way that we model this is that I search, I get tired, I make another search, I get more tired, and then when I take my break afterwards, my search costs are reset to the baseline level. So here we look at what happens if this reset of the fatigue cost does not happen. And so not surprisingly, if this reset does not happen, the number of searches and purchases goes down. What we do next, and I think that's the more interesting part, is to look at how do the effects vary across the different companies. So here, the ordering of the websites is the same as on the slide you saw, I think on the picture you saw 2 slides ago. But what we see here is that the companies that benefit the most from consumers remaining tired are the largest companies. So if they are hurt less, let me rephrase it like this, they are hurt less than the smaller companies. So if I am tired and I will remain tired, then I am just going to focus on the largest and most well-known companies and search and purchase from those. And so that's what I have for today. So hopefully I was able to convince you descriptively that consumers do take breaks when they are browsing online, that at least for our category that we are looking at here, fashion goods, fatigue seems to be to play a major role in whether consumers take a break or not. And I've tried to walk you in through this new sequential search model that not only models which websites to search, whether to continue searching or to stop, but also has this additional decision of when consumers are going to make a search, whether that's going to happen now or after the break. And with that, thank you very much for listening to me. And if there are any questions, please shoot ahead.
Perfect. Thanks a lot, Ella. This was great. I think it's a good moment to wrap up the formal part of the talk, and then we'll go into an informal discussion. If you want to join the discussion, just raise your hand or let us know in the chat or in Q&A, and we'll add you. And I can start with a quick question. I'm kind of following up on the kind of thinking about the exogenous variation. And I'm not sure how much you'll see it in the data and how helpful it is. But I know that if you look at like online news consumption or like some entertainment consumption, what you see during the workday is there is like very large increases in consumption right before the kind of every hour. So for example, if it's 8:55, there'll be a spike in news consumption. And then the story like which you hear a lot of people just before a meeting starts at 9 o'clock, I'll go and consume entertainment or like something like this. And then now like for the next 40 minutes, I'm in the meeting, and then now I get a procrastinate and go back. I wonder, and I'm not sure like how much you'll see it in the data, but I wonder if that can give you some like occasions when like you can use some structure from the browser and like, this will like for sure, like very likely this was not driven by my search process. and kind of like compare the probabilities or like look at those.
Yeah, so you are thinking basically that consumers use those 5 minutes or so for some leisure activity, and that might be the browsing for some clothes.
Correct. So it was like to refer, like I have like a very strong constraint on time on like how much time I have. So I take a gap, I take a break, not because I'm tired, just because I didn't have extra time to search. And so it's kind of it's aligned with you mentioned early on that in the end of the day people take less breaks than I think like I think it was like evidence fatigue in some way, but you can also actually you can think in that sense that maybe I take fewer. In some way it goes against fatigue, because if I'm by the end of the day I'm very tired, I should be taking more breaks. But that I'm not sure like which way we should think about it. But it's definitely aligned with this fact that maybe like during the day I'm working, so like now I'll finish this call and I'll go to read the news for 10 minutes or maybe to browse for a new shirt. And so this might be helpful.
Yeah. So I don't know, Raluca, do you know whether we observe any of such patterns in the data?
I think we looked very early on whether there are more gaps like 5 minutes before the beginning of an hour and 5 minutes after. We didn't see a pattern there. I mean, because we had the same sort of intuition that there's some external factor that affects the decision to stop or to continue. And on top of that, like most cases, right, like I was saying, like 90% of cases or something, people do something else online that we do observe after they're done with their search in the fashion category, so that again suggests that they did have more time. It's not like, you know, the building was burning or, you know, the meeting was starting or something else. So that they did have more time for something else. So
yeah, I think also just, you know, two more things to keep in mind. This is browsing history on a PC. So it's not that I'm doing that, you know, right before, like if I physically go into a meeting, I do that on my phone. And the second point is that this data is prior to the pandemic. So I think, you know, thinking about people being at home and having a lot of Zoom meetings on the computers at home, that might be more likely the pattern that you're describing, but the data is from 2018, I think, if I get the year correct.
Got it. Makes sense.
There was another question Ella was asking whether we think about the length of the gap and how that enters. Yeah,
so we are not modeling that. So I think we had some conversations, you know, it's how long are the breaks that people are taking. We've also had some conversations about, the number of pages, individual product pages that I look at within a website. Does that going to change, you know, the level of fatigue from browsing a website? But I would say, you know, as a first step, we were trying to keep it as simple as possible. So that's why that is not modeled, not because we think that it doesn't matter or that it's not something interesting to look at. It's just, you know, baby steps. Well, they are not really baby steps, but steps.
Yeah, I don't think there was there was a lot of questions in the Q&A along the way that I think Raluca answered, was very efficient to answer those. So I don't say anything else in the Q&A right now.
Sounds good.
I have just speculative question that shouldn't show up in your paper here, but towards the end there, the things that you were pointing to kind of hit towards like what's the exploitability of search gaps from, I mean, you're only modeling the buyer's side, but I was thinking about this, like suppose by examining your cookies or whatnot, I can get this information. I guess this would mean that I would want to like offer a discount to the ones that are further in their search fatigue, knowing that I might be able to snare them where otherwise I know they're just off to the wind. Is there anything else beyond that you think would be kind of the optimal seller response to this behavior?
So I had the slide on that and then I dropped it yesterday. Raluca?
Sure.
I think so. We were thinking about targeting these consumers, about optimal pricing policies in the presence of consumers getting tired and taking breaks. Did I miss anything? I think there was a third one that I forgot.
Yeah, I can't remember either, but yeah, I really like this counterfactual also. Like if we could tell whether someone stopped because of fatigue rather than because they couldn't find what they were looking for, you know, being able to target them at that point would be really great. So we're still trying to figure out if there's a way with our model to construct that counterfactual. But yeah, that would be really cool. Like we don't have, like you said, the firm, like a model of the firm behavior here. But yeah, that could be really cool to see, you know, this person stopped because of fatigue, this person stopped because they didn't like what they, so only target the ones who stopped because of fatigue. That would be really cool.
Yeah, and yeah, another thing that we kind of, you know, we're dealing with is, if you might have noticed, but I did go very quickly over it, is that we don't have price in the utility function. Because how do you define price at the website level? And so that kind of also limits the types of counterfactuals that we can explore. So, you know, if you have good suggestions of how to deal with that, I think we would be very helpful, very thankful for that. Yeah.
That is fun, but I don't think I have any great ideas.
Yeah. Because I think, yeah, you know, price would be one of the kind of primary drivers, let's put it like that, of what companies could use. We thought about some other things as well, but yeah, I think that's a point that the reviewers have also brought up in the process. If one of you is one of them.
Thank you very much. Really appreciate the feedback.
Thank you. Yeah.
Yeah, thank you, Ellen. Thank you,
Brian,
and thank you, Son, for joining for this.
Thanks for the presentation. Very fun paper.
Yeah.
Thank you.
Thank you for inviting me.
Thank you. Bye, guys.
See you all
Bye.
in September.